Hey everyone, welcome back. Today we're doing a deep dive into something that should be on every single developer's radar, a really sophisticated software supply chain attack. And the key word here is clever. This isn't your typical brute force stuff. This is all about deception. So let's get right into it. So let's just kick things off with a pretty provocative question, especially for all of you who write code for a living. Is your code a Trojan horse? I know, it sounds a little dramatic, right? But honestly, it gets right to the heart of the threat we're going to unpack today. And you're right to be dramatic, because this isn't some theoretical threat, some what-if scenario. The entire reason we're talking about this is because of a critical security alert that shows this is happening out in the wild, right now. Malicious code is being slipped into projects, just hiding in plain sight. It's wild. Exactly. So to really get why this is such a big deal, we first need to understand the scale of it all. So for our first section, let's just look at how widespread this campaign actually is. Okay, so how many different fronts are the attackers fighting on? It's not just one, it's four. I mean, just let that sink in for a second. This isn't some random opportunistic hack. No way. They specifically built and deployed malicious code for 4 different programming languages, all at the same time. This is a coordinated attack. And wow, just look at this list. These are not obscure languages that only a handful of people use. Not at all. We're talking about Python, Rust, JavaScript, and Go. I mean, these are the absolute cornerstones for millions of developers. They're building everything from your favorite website to critical back-end systems with this stuff. This hits the very core of the developer ecosystem. So you've got these 4 huge languages under siege. What does that actually mean on the ground? Well, from the initial investigation, we know that at least 24 software packages are at immediate risk of being compromised. That's 24 separate projects that developers are probably pulling into their own code right now with no idea what's hiding inside. And that's where the blast radius just explodes. I mean, this quote from the security alert, it really makes you stop and think. It says, several companies were found to have their entire SDK portfolio compromised. We're not talking about one little open source project here. We're talking about the entire collection of developer kits from multiple companies. The potential for damage is just massive. So we've established the what. We know the scope is huge. Now for the really clever bit, the how. Right. Let's dig into the mechanics of this thing, what we're calling the GitHub Actions heist. So for anyone listening who might not be deep in the weeds here, what exactly are GitHub Actions? Well, think of them like automated recipes. Developers set them up to handle all the boring but super important stuff, building the code, running tests, shipping it to a server. And the key thing, the most important thing to understand is that it's a place of incredibly high trust. You have to give it your secrets, your API keys, your passwords for it to do its job. And that trust is precisely what the attackers used as a weapon. This wasn't a smash and grab job. It was way more subtle than that. It's like a spy who doesn't blow up the factory. Instead, they just quietly add one tiny, malicious step to the official security checklist that everybody follows without even thinking about it. And this is exactly how they did it. It's a pretty slick 4-step process. So first, the attacker contributes a new workflow file to the project. Simple enough. But then, step 2, they disguise it with a name that sounds totally harmless. Third, the commit message, the little note explaining the change, it also looks completely innocent. And just like that, the trap is set. And step 4 is when it springs. The next time the project owner runs their regular updates, that hidden workflow quietly executes in the background and sends all of their secret keys straight to the attacker. It's as brilliant as it is terrifying. Absolutely terrifying. But look, as clever as these attackers were, they weren't ghosts. They left fingerprints. And that brings us to what might be the most critical, most actionable part of this whole explainer. It's time to look at the clues they left behind. Okay, so for all the developers, all the security engineers watching right now, this is your action item. Seriously, pause, take a screenshot, whatever you need to do. This is what you need to be actively scanning your code repositories for, like today. So what are we actually looking for? What's so wild to me is the social engineering here. I mean, look at the names they used: GitHub Actions Security. The commit message is add GitHub Actions Security workflow. They are literally using the language of security to hide the attack. It's brilliant because it's designed to be overlooked. It just looks like another boring, helpful, routine update. Okay, so that's how they hide the trap inside the code. But once that trap is sprung, the stolen data has to go somewhere, right? Exactly. So where's all that valuable information being sent? Well, that leads us to the network clues. These are what the security pros call indicators of compromise, or IOCs for short. Basically, they're the digital breadcrumbs. The security alert pointed to these specific web addresses and this one IP address. And to put it really simply, if your network logs show your system sending any data to these destinations, that is a massive, flashing red flag. It's a sign that your secrets are being siphoned off in real time. All right, so we've covered the threat, the method, and the evidence. As we start to wrap up, let's kind of zoom out and talk about the bigger picture here. Because an attack like this, it really forces all of us to rethink some fundamental ideas about security in the world of software. It's time to talk about the new rules of trust.
You know, for a long, long time, the model was pretty simple. If a popular open source package did its job, you just trusted it. You pulled it in. That was then. Security was kind of a separate step, something you bolted on at the end. But now, that has to be completely different. The new rule has to be trust, but verify the code. Security isn't an afterthought anymore. It has to be a part of every single code change, every single commit. The era of blind trust is just over.
And that really is the heart of the issue, isn't it? The entire open source world, this whole software supply chain we all depend on, is built on a foundation of trust. It has to be. It relies on the basic belief that people are contributing in good faith. And this attack weaponizes that very trust. It turns a project's own helpful automation against itself.
Which leaves us with this really big and, frankly, pretty uncomfortable question. We have built this incredible system where literally anyone in the world can contribute code and collaborate on these massive, important projects. But when that openness itself can be turned into a weapon, who's actually responsible for keeping it safe? Is it the person who maintains the project? Is it the contributor? The platform like GitHub? There's just no easy answer to that.
And on that note, we'll leave you to chew on that one. Thanks so much for joining us for this deep dive. As always, stay curious and please keep those questions coming.
Until next time, keep scrutinizing.